Hi guys, here's the next lesson in this chapter. It is on a geometric series. There is a typo or two, go figure, in these notes. So a geometric series is the sum of a geometric sequence. If we would have done arithmetic series, it would have been the sum of an arithmetic sequence. But we're going to just do geometric series since we've only done geometric sequences. So it's just the sum. Remember, sum means when you add things up, it's the answer to an addition problem. And you can have a finite geometric series or an infinite geometric series. And we're going to do finite geometric series in this lesson. So the formula for the sum of a finite geometric sequence is below. So that stands for the sum or the series of some term is equal to our first term, a sub 1, and then 1 minus our common ratio to the n power, whatever term we're trying to find the sum up until, and then all over 1 minus r. These aren't terribly difficult because you're simply following a formula. However, if you do the wrong algebraic steps, you're going to get the wrong answer. So you need to make sure that you follow the same order that I do these problems when you do these problems on your exit slip. So our first example says, find the sum of the first 16 terms, which just means, n is 16, of the geometric sequence with a sub 1 equal to 500, which means our first term is 500, and our common ratio is a half. So again, we're going to follow this sum of a geometric sequence formula and plug in everything we know. So we know we're trying to find the sum of the first 16 terms. So we're going to do sum of 16 terms equals 500 is my a sub 1. Then we have 1 minus, the problem gave me that r was a half, our n, the number of terms we're trying to add up was 16, and it's all over 1 minus r, which again is a half. So here's where you have to be extremely careful. Well, this one, I guess, actually, no, we're not really solving for anything. On this one, it's not too bad. You could honestly put this all into your calculator, and it's approximately 1,000. A lot of these don't add up to like perfect, pretty numbers. So it's approximately 1,000. If you type it in just like that, you should be just fine. Just make sure all the parentheses are exactly where they're at here. You may run into some problems if you do try to kind of simplify that down, if you don't follow order of operations right. So it may be your best bet to type it in exactly like it's written there. So anyway, when you add up the first 16 terms in this geometric sequence, you're going to get approximately 1,000. So that's what that means. So we're adding up the numbers in a geometric sequence to get our series. All right, here's where you have to really kind of pay attention to the algebra, the order of operations. So example 2 says, and I wish I could type this all out and it wasn't already written, but hopefully it's all good. And of course you can always come to a help session if you need help solving these, but it says, find the number of terms in a finite geometric series with n terms if a sub 1 is 2, so I know my a sub 1, my first term here is 2, so I know that's going to go in here. If r is equal to 3, so where r is in my formula, I'm going to put 3, and on this one, I know that when I add up however many terms, I don't know, that's what I'm solving for. I don't know how many terms I added up, but I know when I added up these terms, I got that the sum was 80. So I know that part's 80. So we know everything except for this n. We have to solve for that exponent. And the reason these are tricky is because what we're solving for is an exponent. So step 1 would be to write down your formula, plug in everything you know. So when we plug in everything we know, it looks like this. So 80 equals 2 times 1 minus 3 to the n power, all over 1 minus 3. First thing you're going to want to do is divide by this 2 out front. So whatever number it is when you do a problem, that would be my first step. I would do 80 divided by 2, which is 40. At that point, you can also simplify the denominator. So we know 1 minus 3 does give me negative 2. At this point, It's about as simplified as it can get. I need to get rid of this fraction. So remember, to get rid of a fraction, I can multiply both sides by that -2, and it'll get rid of the -2 in the denominator. So when I do -2 times 40, I'm back to having a -80. So now I have -80 equals, and I still have this whole thing on top. So 1 minus 3 to the n power. To get to this n, I need this 3 to be all by itself. So first thing I would do is subtract this 1 and put it on the other side. So -80 minus 1 is -81. So we have -81 equals -3 to the n power. I need to get rid of this negative sign, so I'm going to divide both sides by -1. So when you do that, -81 divided by -1 turns into a +81. My -3 divided by -1 turns into a +3. Then you have to remember good old logs, and I know a lot of you guys didn't like this, but to get this n down, I can multiply this side by a log with a base of 3. This log base 3 cancels with this 3 and brings that n down. But what I do to the right, I have to do to the left. So since I multiplied this right side by log base 3, I have to multiply this side by log base 3. Now remember, some of you guys' calculators did this. A lot of you guys have calculators where it's the base is 10. So remember, to type this into your calculator, you're going to do log 81 divided by the log of the base, which is 3. So you would do log 81 divided by log 3, and you should get 4. So you may want to practice typing that in. Remember, if you remember that the base is always on the bottom, it's always what you're dividing by. Base is on the bottom. So log 81 divided by log 3 is 4. And that's honestly like that for like every single problem. You're going to, well, not every single, your first one, your exit slip is like my first example, and then your second two are just like this. So you're going to want to follow them the exact same way. All right, our last example says to find the number of terms in the finite geometric series with n terms below. So we're giving it to us in like a different way. I can see the sequence written out. So I can see that my first term is the 81/4. And I can use what I know so far to figure out r. So if you were to do 27/2 divided by 81/4, you should get that r is 2/3. Or if you do 6 divided by 9, I mean, that's even a little bit clearer, you would see that the r in your formula, that common ratio, is 2/3. We also know that a sub 1, our first term, is 81/4. So just looking at that sequence listed out there, I have a lot of information. Then within the problem, they tell me that S sub n is 2059/36. So I'm going to substitute that in where it belongs. So again, here's where I'm going to have to use some algebra skills to solve to figure out what this n is. So just like before, and this one's just a lot uglier, I would take what I highlighted in pink and divide it by what I highlighted in green, or multiply by the reciprocal, whatever. You should get 2059/729. So all I did is divide that on both sides so that it would go away. So now I'm left with, I have 1 minus 2/3 n on top still. To simplify the bottom, 1 minus 2/3 is 1/3. So that's now simplified. Then remember, to get rid of a fraction, so that you no longer have a fraction, you multiply by whatever that denominator is. So I would multiply by 1/3, those would cancel, multiply by 1/3 over here, and you get this number now, 2059 all over 2187. I still have what was on top of my fraction over here. So my 1 minus 2/3 to the n power. Next thing I'm going to want to do is, because I want to get this 2/3 all by itself, is I'm going to subtract 1 from both sides. When you do that, you get this lovely number, -128 all over 2,187. On the right side, we're still left with this negative 2/3 to the n power. Divide both sides by -1. Basically just makes everything positive now. Then remember, to get this n down, we're going to multiply both sides by a log of base of 2/3. And the reason is because this log base 2/3 cancels with this 2/3, and I'm left with just n. So now in your calculator, you're going to type log of 128 divided by 2,187 divided by log of 2/3. And when you do that, you should get that they added up 7 terms. So n is 7. And that is your answer. All right, so that concludes this video. So this was on the finite geometric series. You can now complete Wednesday's assignment, the geometric series exit flip. Have a fantastic day.